Welcome back. Today we'll look at combinations of transformations. For each of these graphs, I'm actually going to write down the table as well, just so we can practice seeing what happens to the transformation. So the first one right here, we have negative f of x plus 2. So I'm going to make sure we use almost kind of an order of operations. We're going to focus on the parentheses first. So here we have this function f, right? And when we see plus 2 inside the parenthesis, that means we're going to have a shift left 2 units, or translate 2 units. I'm going to put translate over here. So what that means is we're going to have each of these points here, and I'll move my cursor. So this is negative 4, 2. This is negative 2, 4. I'll use this point, which is negative 1, 3. And then we'll use this point up here, which is 1, 7. So I'm going to write these points down here so that we can see what happens to them. So we have negative 4, 2, negative 2, 4, negative 1, 3, and 1, 7. So each of these are going to be shifted to the left 2 units. So that, remember, we're looking at this x coordinate, and so we're going to subtract 2 from the x. Okay, so we're going to get these new points, which is negative 6, 2, negative 4, 4, negative 3, 3, negative 1, 7. So we're shifting all of those to the left. So you could kind of see over here in the green, I'm going to keep this navy blue. So here's negative 1, 7. You could see negative 3, 3, negative 4, 4, and negative 6, 2. All right, so now we're going to focus on this negative. So we worked in the parentheses, and now we're going to look outside. So this negative outside says we're going to reflect the function on the x-axis. So it's going to essentially make the y's negative. So if we go down here, you can kind of see, I'm going to just show a picture here, but see how it's reflected on the x-axis. So every value here becomes, the y becomes negative. So now I'm going to say we're going to multiply by negative y. So this is going to be negative 6, negative 2, negative 4, put a little arrow here, negative 4, negative 3, negative 3, and negative 1, negative 7. So you can see those points here. I'm going to zoom out a little bit, but you can see those points here. So you have negative 6, negative 2 right there, negative 4, negative 4, negative 3, negative 3, and negative 1, negative 7. So when we graph it and we're looking at the combination, we're trying to stay with that order of operations in a way. Okay, let's look at the next one. All right, so this one here, we have f of x. So you can kind of see that this 1/2 is in front of the f of x. So that means it's going to be a vertical compression. It's going to push it down so it's flatter. So I'm going to put these points here, and they're the same from the previous page. So that was negative 4, 2, negative 2, 4. I'm going to make some more room here. Negative 2, 4, negative 1, 3, and 1, 7. So what's going to happen is that each of these y values, because this is in front of the f of x, each of these y values will be multiplied by 1/2. So essentially, remember this f of x is really representing y. So you can say, okay, that's 1/2 y. So we're going to get these points, -4. I'm going to move it over a little bit. -4, 1, -2, 2, -1, 1.5, and 1, and I'll put 3.5. Okay, so you can have it out there. So looking at this graph down here, you can see these points. So -4, 1's right here, -2, 2, -1, 1.5, and -1, 3.5. So that y ends up being cut in half. Okay, now we're going to do this translation here. And so this is a +3, so that means we're going to add 3 to the y, because it's going to go up 3. So I'm going to take this number here and add 3. So it's going to be -4, 4, -2, 5, -1, 4.5, and 1, 6.5. So we're going to see that shift up here, and you can see it here in the orange, but here's 6.5, here's -4, 4, -2, 5, that was -1, 4.5. Okay, so you can see that shift up. All right, so we're looking at those points. We had to work kind of in a similar way with order of operations. So this is multiplying right here. So we had to make sure we multiplied that y by 1/2 and then added 3 to the y. Okay, now we're going to kind of work in the opposite direction. So now we have the equation and we want to say what happens to the graph. Now I graphed it already, so I just want to make sure you know that. So when we see this equation, I'm just going to zoom out a little bit here. You can see right away there's going to be a couple things that happen. So this is a parabola. Anything that's x squared is going to be a parabola. Okay, so anything, it's going to be the squared function, right? That's going to be the parent function. Well, there's a couple things that happen. The first is everything's going to be, it's a horizontal shrink. So we're going to actually have a compression, a horizontal compression as well. So it's going to be 1/3 of, well, I'll look at those points, but essentially everything is going to be elongated on the x and then vertically shrunk. So let me first do a couple things. I'm going to just make a couple points here. Okay, so if we know that the parent function, and I'm going to say f of x is x squared, I'm just going to put a couple points. So we know that -4, I'll put -2, 4. So if I plug in -2, I'll get 4. If I plug in -1, I'll get 1. Plug in 0, I'll get 0. 1, I'll get 1, and then 2, I'll get 4. So you don't have to show the points. I'm just showing just so you see what happens to the values. So the first step is looking at this green function, this h right here. So this is what we did right here, is we're going to say we're going to multiply all the x's by 3. So it's going to be, it's actually the reciprocal. Remember, anything that's in the parentheses is kind of, you can say, the opposite. So when we have the 1/3, it's kind of stretching it out horizontally, or you can say a vertical compression. But what I'm going to do is I'm going to multiply all these x's by 3. So it's -6, 4, -3, 1, 0, 0 just stays put, 3, 1, 6, 4. So I just want you to see this graph here. So -6, 4 is right here. -3, 1, well, it's going to be here, but you could say it right there. And then you can have 1, 1, or 0, 0, 3, 1, which is over here. And then we have 6, 4. Okay, but you could also see that 4, 2 is also on there. Okay, now let's go to this negative that's outside. So remember, when we have a negative that is outside the parenthesis, that means it's being reflected on the x-axis. So it means all the y's will become negative. So I'm going to use this transformation. So it's -6, -4, -3, -1, 0, 0, 3, -1, 6, -4. So you can see right here, after we apply both transformations, we'll go from the blue graph, which is the parabola, to the orange graph. And we had to use that green graph kind of as an intermediary because there were two things that were happening inside this equation. We had to have that horizontal stretch, right? And then we had to have, so horizontal stretch here. And then we had to have the reflection on the x-axis. Okay, let's go to the next problem. So for this one, we have two things that are happening. So the first thing we have is inside the parentheses. So it's going to be a shift 4. So I'm going to put those points again here for just a regular parabola. So -2, 4, -1, 1, 0, 0. And this is if our original was just x squared. Okay? And then 1, 1, and 2, 4. So we're going to have that shift to the right 4. So we're going to add 4 to the x. So this is going to become 2, 4, 3, 4, 4, 0, 5, 1, and then 6, 4. Okay, and you can kind of see here's 6, 4, 2, 4, 4, 0. Okay, and then for the next step, we're going to add 5 to the y. So just to the y here. So let me just make sure that's corrected to 1. Okay, so here we're going to add 5 to the y's. So we have this new coordinate would be 2, 9, 3, 6, 4, 5, 5, 6, 6, 9. And you can see these points here. So 2 9's about right here. You can kind of see because it goes by 2's there. And then we have 3, 6, and 4, 5, right? And then 5, 6, and then 6, 9. So you can see that shift. Okay, for the last example, we're going to write an equation from a graph. So this one has a scenic train ride, makes trips on an old mining line. And the distance y in kilometers from station X minutes after the ride begins. So you can see that as time progresses, this train is going at a steady rate away from the train station. And then when it's 15 minutes and 15 kilometers away, it starts coming back. So it's at a steady pace, and so at 30 minutes, it's completed that round trip. Now we want to write an equation for this, and we know that anything with a V shape is going to be an absolute value function, right? So we definitely know that. And we have a couple things that are happening. We have this absolute value, and I'm just going to write this original here. We have a couple things that are happening, right? So here's the absolute value. We have it shifted, right? It's being shifted to the right and up. And then it's also upside down. So we know that everything is being reflected. So I'm going to do one thing at a time, and we're going to first reflect it. So y equals negative absolute value of x. Okay, so if it's negative, I know it's going to be down here. And then we're going to make sure it shifts to the right 15 and up 15. So if it's going to move to the right 15, we know it's going to be x minus 15. That's right 15. And then we know if it's going to go up 15, we're going to have to add 15. So this equation is going to be y equals negative times the absolute value of x minus 15 plus 15.